Dry friction is what happens when two surfaces try to slide against each other, but either don't move or resist moving. Imagine you're trying to push a box across the floor. At first, it doesn't move because of friction, but once you push hard enough, it starts sliding. That's friction in action. There are two kinds of friction forces you need to understand. One, static friction. Static friction is the force that stops an object from moving when it's at rest. It acts like a grip, holding the object in place. The formula for static friction is less than or equal to the coefficient of static friction multiplied by the normal force. Or simply, static friction equals mu's times normal force, where mu's is the coefficient of static friction. 2. Kinetic friction. Kinetic friction is the force that resists motion when the object is already moving. It acts like a drag that slows the object down. The formula for kinetic friction is kinetic friction equals muk times the normal force, where μk is the coefficient of kinetic friction. Let's break this down. Step 1. What is the normal force? The normal force is the force that the surface pushes up with, balancing the object's weight. In most cases, it's the same as the object's weight. For example, if an object weighs 50 kilograms, the normal force is equal to 50 kilograms multiplied by gravity, which is 9.8 meters per second squared. So in this case, the normal force would be 490 newtons. Step 2. What are mu's and μk? Mu, as the coefficient of static friction, is a number that shows how sticky the surface is when the object isn't moving. Μ, the coefficient of kinetic friction, is a number that shows how sticky the surface is when the object is already moving. The values of mu's and μk depend on the materials involved. For example, rubber on concrete has a higher value than ice on steel. Step 3. How to use the formulas. For static friction, the static friction adjusts itself to prevent motion until a maximum value is reached. This maximum is equal to μ times the normal force. If the applied force is less than the maximum static friction, the object won't move. For kinetic friction, once the object starts moving, the friction force becomes constant. This value is equal to μk times the normal force. Real-life example, moving a box. Imagine you're trying to push a heavy box across a wooden floor. Let's calculate how friction works step by step. Step 1. Calculate the normal force. The box weighs 50 kilograms. To calculate its weight, multiply the mass by gravity. Gravity is 9.8 meters per second squared, so 50 times 9.8 equals 490 newtons. This is the normal force. Step 2. Use the coefficients of friction. Let's say the coefficient of static friction, mus, is 0.4. The coefficient of kinetic friction, muk, is 0.3. Step 3. Find the maximum static friction. The formula for maximum static friction is static friction equals MUES times the normal force. Substitute the values. Static friction equals 0.4 times 490, which equals 196 newtons. This means you need to apply more than 196 newtons of force to make the box start moving. Step 4. Calculate the kinetic friction. Once the box starts moving, the friction force becomes constant. The formula is kinetic friction equals MUK times the normal force. Substitute the values. Kinetic friction equals 0.3 times 490, which equals 147 newtons. So, while pushing the moving box, you need to overcome a resistance of 147 newtons. Exercise for you. Here's a question to test your understanding. A car tire on a flat road weighs 1,000 newtons. The coefficients of friction are: the coefficient of static friction, MUS, is 0.8. The coefficient of kinetic friction, MUK, is 0.6. Now answer these two questions. 1. How much force is needed to start the car moving? 2. What is the friction force once the car is moving? Write your answer in the comments. Take a moment to solve the exercise, write your answer in the comments below, and let's see how many of you can get it right. Wrapping it up. Friction is everywhere. whether it's your shoes gripping the ground or a car slowing down. Understanding these simple concepts can help you solve real-world problems with ease. Did you find this explanation helpful? Let me know in the comments. Don't forget to like, share, and subscribe for more simple and fun explanations of science topics. Until next time, keep learning and stay curious.